Alright, let's solve the inverse Laplace transform. So this is example 2. I'm hoping that you've seen my first example and the following video where I explain what the main ones from the table you need to memorize, so to speak. So let's go get into it. So like I said, it follows basic integral rules. I can bring this 11 out the front, so it's now 11 multiplied by the inverse Laplace transform of now 1 over s squared plus 2s plus 10. So what do we do here? So one thing I didn't explain is, like there's so many tricks that you need to know, and one of them to solving inverse Laplace transforms is completing the square. So I'm going to take this middle term here, 2, divide it by 2, so that's 1, square it, 1. So that means that's 11 multiplied by the inverse Laplace transform of 1 over s plus 1 squared, because I know that's going to give me a 2s now, and because now that's a perfect square, because I realize that if I divide this by 2 then square it, that's going to give me 1, which means that s plus 1 squared is a perfect square, which it is, and then I have to subtract 1 as well, because I just added 1 out of the blue, obviously, so this is going to be plus 9. And if I, expanded s plus 1 all squared plus 9, I'd get this back. So this is actually 11 multiplied by the inverse Laplace transform of 1 over s plus 1 squared, and then I can say that this is the same as plus 3 squared. Is this starting to look familiar? You know what I mean? So now what I can do is a neat little trick. I am going to multiply top and bottom by 3, because this is now in the form of the inverse Laplace transform of b over s minus a squared plus b squared, which was just equal to e to the at sine of bt, right? You remember, if you've watched my table video, you will see that this is practically the same thing. And if I multiply top and bottom, remember I can bring this 3 out the front if I wanted to, but I'm not going to, because I want it to be in there, because then that means I can apply the rule. So the final answer is going to be 11 over 3. Because it's s plus 1, again, because I have a plus sign in the middle, that means my exponential is negative, because the rule is when it's s minus a, you have a positive exponential. So that's how I know it's going to be a negative exponential, and it's negative a, so it's e to the minus t sine of bt, which is 3. And that's the final answer for that inverse Laplace transform. So this example will consist of using the rule where I pull the coefficient out the front, completing the square, and then recognizing that I can just manipulate this to become 3 squared, and then multiply top and bottom by 3, and I have my answer. So that is how you do an inverse Laplace transform. Again, it's going to be a lot more examples where it's a lot more trickier, and it's going to have all of them in one. So yeah, for a short video, I wish it wasn't so short. It was kind of fun. So yeah, I've got a lot more examples. I'm telling you, I'm going to do a heap, because I need to learn it too. So yeah, see ya.